It's probably one of the first facts in geometry that you really learn. And it is a fact concerning these kinds of triangles, right triangles, triangles that have one right angle in them. And what this fact says is that given a leg, so one of the sides connected to the right angle, and another leg, B, and the hypotenuse, so the side across from the right angle, these sides are related by the equation a² plus b² equals c². And if you're watching this video, you have probably committed this to memory at this point. It is a very famous fact called the Pythagorean Theorem. And you're usually shown this and told that it's the case, but you're not usually shown why. And here I want to offer a proof of that Pythagorean theorem. So a demonstration on why it is true. And we're going to use some facts about similar triangles. So in case you're a little rusty on similar triangles, let me find a part of the screen that I haven't used yet. So we say two triangles are similar, and let me find the right color for this. So let's say we've got this triangle, ABC, and we've got another triangle. Let's use the next letters in the alphabet. Let's say D, E, F. We say that these two triangles are similar if their angles are the same. So if they've got, and you see these kind of concentric lines I'm drawing mean that their corresponding angles are the same. So if their angles are the same, then we say that the triangles are similar, and that implies certain things about the relationship between these sides. So we can say that the ratio between A and D, so between two corresponding sides, in a corresponding side, I basically like to look at it as they're across from the same angle, so that's one way of thinking about it. So the ratio of corresponding sides is going to be the same, so let's find another pair of sides we can compare. So A over D is the same as C over F. So we can say that about these triangles. We can also talk about the ratio between sides on the same triangle. So we can say that A over C is the same as whatever that corresponding pair is on the similar triangle. So in this case, it would be D over F. Okay, so this property that the ratios are the same is something that we're going to use when we prove the Pythagorean theorem. So let's get to it. I'm going to bring this right triangle into focus here. And you see I've labeled the angles that aren't 90 degrees, alpha and beta. Those are just Greek letters for A and B. And yeah, we've got this triangle, ABC. We don't really know much about it except for the labels that we've given it. So I'd like to introduce something to this picture. And this is going to be kind of the key step in our proof. So I'm going to draw a line that forms a right angle with side C over here. And so let's label these two lengths that we got split up into, that we got the C split up into. So we got x. Oops, sorry, let me switch my pen here. We got x and we've got y. And something we can immediately say about x and y, because it's literally how we created them, is that when you put them together, we get c. Now we're going to save this fact for later, but it's important kind of first step is outlining, what are the facts that we know about this triangle and its sides. Okay, now what we did when we introduced this line is we split this triangle into two separate triangles. And more importantly, these two triangles are both right triangles. Now what can we say about the angles of these triangles, the interior angles of these triangles? So I'm just going to draw, each of these triangles out. So we have our original triangle, the one with side lengths A, B, and C, but we also have a right triangle with a hypotenuse of B, and we've got side length Y here. We don't really know what this bit is, but we are going to, we're only actually going to be needing these two sides, and you'll see why in just a little bit. And what other triangle? We've also got this small triangle over here. So I'm going to sketch a small triangle here, and let me just do a little bit better than that. Okay, what can we say about this small triangle? Well, we could say that this side is A, and this side is X. Okay, and we can also say, between A and X, we've got the angle beta. Okay. Now, we know that these are both right angles because, that's kind of the situation we had on our diagram. But notice something about this original triangle. So A and B should add up to something, and that something turns out to be 90 degrees. Because, and I'll probably go over why in a separate video, the interior angles of a triangle always add to 180 degrees, or if you like to think about it this way, we call that a straight angle. So once we take away this 90 degrees, what we're left with is 90 more degrees, and we know that these two have to sum to it. Now look at these triangles. We've got a 90-degree angle here. We've got alpha here. So what do we need to finish the 180 degrees? Well, we need a beta. And over here, well, we've got a 90 degrees and we've got a beta. So what do we need? We need an alpha. So now look at this. We've got all three interior angles the same on all of these triangles. They are all similar triangles. And this is crucial because now we're going to use that fact to see if we could rewrite x and y. So let's use that fact about similar triangles, that the ratios between their corresponding sides are the same to help us rephrase x and y. Okay, and let's think about this by comparing these smaller triangles to kind of this larger one where we know the sides in terms of A and B and C. So looking at this triangle and comparing it to the big triangle here, well, the two sides that we know are y and b. So let's make a ratio between those. So for this triangle, we'll say y over b. And let's see what that corresponds to on the bigger triangle. So b is our hypotenuse. It is across from the 90-degree angle. And y is across from angle beta. let's see what sides share that same property on this triangle. So across from the 90-degree angle, we have C. And across, so let's see. Oh my God. Okay, so the first side is going to be across from beta. So on the big triangle, that is B. And then we look at the one across from the 90-degree angle, which is C. And so how can we rewrite y then? Well, we can say that y, so if we multiply both sides by b, then b gets canceled here, and we are left with b squared over c. So that's our y. Now, what about x? So let's see if we could make the same comparison for x. And yeah, so x is across from angle alpha. So let's compare x and a. We'll say the ratio between x and a. Well, what side is across from angle alpha on the big triangle? Well, it is just a. And then, of course, A is across from the 90-degree angle, and that side on the big triangle is still C. And so we can say that x, and I'm running out of room a little here, I'm gonna move over just a little bit. So we can say that x is equal to a squared over c. Okay, so now we've got x and we've got y. What can we do with this information? Well, let's take it together and put it back with the sum that we had at the beginning, the one that we kind of created for ourselves from the diagram. So we know that x is equal to, I'm gonna actually give this its own space here, just so we can kind of get some more space. So let's take this fact and rewrite it now. And I am going to write this in a nice red pen. So we've got x plus y equals c, but we know that x is just a squared over c. And we know that y is just b squared over c. And what is that going to get us all together? Well, that's going to get us c. Can we simplify this any? Well, yeah. C is the denominator for both of these fractions. So we can rewrite this as a squared plus b squared over c equals c. And you might have some something going off in your head telling you where this is going next. The last step that we need to get the a squared and b squared by themselves is to multiply both sides by c. And when we do that, we get a squared plus b squared equals c squared. And this is the Pythagorean theorem.